Hey guys, welcome back. So what we're looking at today is lesson 13, solving systems of equations. So last time we looked at systems, now we want to take and look at solving them. So matching graphs to systems. Here are systems of equations graphed on a coordinate plane. Match each figure to one of the systems of equations shown here. So our first one is y equals 3x plus 5 and y equals negative 2x plus 20. So if we look at these, we want to find a set of equations that has a y-intercept at 5 and also at 20. Well, these are down in the negatives and 0. This is at what looks like maybe 12 and a half and over 25. Here is a y-intercept at 20, and here's a y-intercept at 5. So this is A. Our next one, we have y equals 2x minus 10 and y equals x minus 4. So same idea, we're looking for those y-intercepts to help us. So it looks like this one is at negative 1, that one's at negative 10, so this is C. All right, and the last one, y equals 0.5x plus 12 and y equals 2x plus 27. So if we look, we said this one was above, this one was at about 12, so it is B. Now, find the solution to each system and check that your solution is reasonable based on the graph. So we want to take and actually solve these system of equations and then check it with the graph, not use the graph to solve it. So on this one here, we have y equals 3x plus 5 and y equals negative 2x plus 10. Now, there are different ways to solve system of equations. There's what's known as substitution, and there's what's known as elimination. I'm going to use substitution on this one. So because each of these equal y, we could set them equal to each other. So 3x plus 5 equals negative 2x plus 20. So then I'm going to add 2x, add the 2x. So then we have 5x plus 5 equals 20. Subtract 5. So 5x equals 15. Divide by 5. So x equals 3. So we know the x coordinate of our solution. Now, the thing is, with system of equations, we don't just have a single number for a solution. We have a coordinate or an ordered pair for a solution. So we not only need to find what x is, we also have to find what y is. So now that we know what x is 3, we can plug it back into either one of these equations, and I'm going to show you both just to show that it does actually work. So we'll have y equals 3 times 3 plus 5. 3 times 3 is 9, plus 5 is 14. So 314 should be our solution. Now, going to double check it with this one right here. So we have y equals negative 2, parentheses 3, plus 20. Negative 2 times 3 is negative 6, plus 20 is 14. So just like I said, it doesn't matter which equation you use. When you plug your initial solution back in, you're going to get the same answer both ways. And if we look, 314, we're a little less than 5 and almost to 15. 314 is a reasonable solution for this. All right, this next one I'm going to show you with elimination. So this isn't the best equation to use as an elimination example, but I do want to show you what that looks like. So when we do elimination, we want to get one of our variables, I should say, one of them to have the same coefficient. So if we look, our x's have different coefficients. One's 2, one's 4. We can't work with that. But the y's both have a coefficient of 1. So being as they're the same, we're going to subtract these equations. Now, if they would have been 1 and negative 1, we would have added them, and that's perfectly fine. So 1y minus 1y, those cancel out, so 0 equals 2 minus 4 is going to give us a negative 2x, and negative 10 minus negative 1, so really negative 10 plus 1, is going to give us minus 9. Now, here's the part where this one isn't necessarily ideal. We have this 0 over here because these are better set up for substitution than elimination, but it still works. So I'm just going to add the 9 back over. So we'll have 9 equals negative 2x, divide by negative 2. So x Oops. I don't want to do it that way. Remember, we write these as pairs. So 9 divided by -2 is going to give us -4.5. So now we plug that back into one of the equations. So I'm going to do it to the first one. So y equals 2 times -4.5 minus 10. 2 times -4.5 is going to give us a -9 minus 10, which will give us a -19. So our solution here is -4.5, -19. So let's look. On C, yeah, that's almost to 5. That's almost to 20. Intersection and solution, it works. All right, and the last one, graph B. So I'm going to go ahead and use substitution on this one. So we're going to have 0.5x plus 12 equals 2x plus 27. I'm going to subtract the 0.5x. So we have 12 equals 1.5x plus 27 minus 27. 1.5x equals, we're going to take 12 and subtract 27 from it to get -15. Divide by 1.5, divide by 1.5, and that's going to give us a -10. So x is -10. Now we plug that in. I'm going to plug it into second one. So y equals 2 times -10 plus 27. 2 times -10 is -20. Plus 27 is going to give us a +7. So -10, 7 is our solution. And if we look over here, we're at -10. We're almost to 10 there, so that'd probably be about 7. So our solutions make sense. So different features there, looking for these solutions to our systems. So solutions is your key word for this lesson. Now, there are different types of systems. So what we were just looking at were a series of one solution systems. So these systems, and we're not going to do the interactive part of this, we're just going to look at what each of these things mean. So these systems, when they have one solution, we have two lines that cross at a single point, which is the only solution they share. So all the ones that we just did, those are all one solution systems. Now, it is possible to have zero solutions and infinitely many solutions. So zero solutions are going to be two lines that are parallel. Two lines that are parallel, never intersect, so no common solution. And then last but not least, infinitely many solutions. It's where the two equations represent the same line. So such as having 2x minus 5 and having 1/2 times 4x minus 10. These two equations would represent the exact same line. We just have to distribute on the second one, and then we'd have 2x minus 5, which means they'd be the same, so they'd have infinitely many solutions. So when we have it so that every single point along there is a solution for it. So this goes back to looking at our infinitely many when we have the same lines. Zero solutions where we have the same slope but a different constant. That's the zero solutions. Same slope means they're parallel. And then one solution is everything else. All right, if you guys have any questions, feel free to ask. Have a wonderful day.